Hi everyone. Today I'm going to introduce you to Tracker, and this is a video analysis software package that you're going to use later in the week to study projectile motion. Now when you go into the lab, you're going to fire up the laptop computers on the desk, and you should notice a little icon like this that says Tracker. You give it a double click, and it fires up here, and this is the window that you're going to work in. Now today what I did is I made just a simple little video that I can use to teach you the basis of the details of how to work this. So to find my video, and you'll do the same thing later this week, is you go up to this folder, give it a leftmost click. The movie I want to use is called My Movie. I open it, and it loads in, and here you have it. You can actually play this movie. You can go down to this green arrow, give it a press, and what you see is you see a ball rolling across the screen. What I have here is I have the camera pointed down on the ground. I have a piece of paper, and I just rolled the ball across the ground this way. And I want to figure something out about that motion. In particular, I like to know how fast it's moving. So there's a couple things I have to do in order to start to extract some information from this. First thing is I want to put a coordinate axis on here. So you go up to here, this little pink axis, give it a click. It appears in the middle of my video. If I put the mouse right in the center, hold down the leftmost key, I can actually bring that axis over here, which is what I'm going to do. There's actually no problem with it in the center, but I find it a bit more convenient. What this is saying is this is the x-axis, this is the y-axis, and this is the origin. So that spot right there would be, if the ball landed right there, it would be at x position 0 and y position 0. The other thing I need to do is scale this so that I can get meaningful numbers out of it. Because when you film something such as a ball rolling through here, unless you give it a scale, you really don't know how big the ball is. It could be a little ball or a big ball. It could be a planet rolling through there. So the way you do that, you go up to here and click on this icon here, leftmost click, pick new, and select calibrate stick. And here's my distance. It's 20 centimeters, which is 0.2 meters. So go in here, I put 0.2 in that box, and that means 2 raised to the power of 10 to the minus 1, so that's 0.2 meters. And you'll notice there's a little blue line here with kind of end axes. If you put your mouse at one corner, hold down the leftmost key, you can drag this to the top of my 20 centimeter line. Go over, do the same with the other one, hold down the leftmost key and bring it here. And now you have just told the computer that this distance is 20 centimeters, which it is. Now, the next step, you go up here to where it says create, and you click on that, and you select point mass, which just means we have a single object going through here, and it's not doing anything particularly strange. It's not like a hammer flying through the air. It's just a single object sliding along. And we can actually close that. I can move the frame forward one video frame at a time. And I can click this, and you'll see it's coming along, and I should see my ball in a second. And there it is, first time it appears. Now I can track this. I can actually get meaningful points. I can get its position as this thing moves along here. And how you do that is you hold down the shift key, and when you do that, notice your mouse turns into this little sort of box. Put that right on the center of the ball and click the leftmost key. And notice it moves forward. The ball moves forward. Now you can do it again. Put your mouse in the center, hold down the shift key, click your leftmost button, and Now I have 2 points, and the balls move forward. Once again, most in the center. You want to keep using the same point on the ball. Shift, hold down the shift key and the leftmost button, click. There it advances forward, and I keep doing that all the way along, and that's what I'm doing. Shift, click, shift, click. And notice over here there's actually a graph appearing of X position versus time. I want to get all my data points, and I want to take some time with this because the analysis I do is going to be based on this data, and I want to be as close to the center of the ball as I can be. If I'm sloppy and I click over here or to the side, I'm essentially telling the computer that the ball is wiggling as it goes, and it's not. That would be me wiggling. So I do the best I can. And that's probably pretty good. And there I have all my points. And again, if you go over to this graph, you'll see you have X position as a function of time. Notice the X position is decreasing with time. Well, that's actually true because here's my X-axis. The ball is headed this way to my left. Now I can go up here. I can put my mouse on top of the X, do a right mouse click, and pick Y. And now I have Y position as function of time. And here the Y position is increasing with time, and that's true here because this is Y equals 0. This is increasing Y, and the ball is headed in positive Y direction. Now it'd be nice to figure out the velocity of the ball, particularly what's the velocity in the Y direction, what's the velocity in the X direction. And the way you can do that is, let's start with X. Go back, let's choose X again. Put your mouse on top of a data point and do a right mouse click and go down to Analyze. And you'll see the graph gets a little bit bigger. I have data table of all my points. These are in meters, the X position. The time is in seconds. And one thing I do is let's turn off the line so I just have data points. And if I notice this looks very much like a straight line. If you remember a little bit about the physics that you learned in high school or that you're learning right now in university, a position versus time graph, if it's a straight line, you have a constant slope, that means constant velocity, which makes a lot of sense for a ball rolling across the horizontal floor. So let's see if we can get a velocity value for that. So we go up here to Analyze, and we do curve fit. And look what we have down here. This is the equation. It's put in the best fit line for these data points. And notice it fits really well. This line, straight line, actually goes through, I'd say, every data point. And it's fitting a straight line. This is X equals AT plus B. So this is equation of a straight line, where A is the velocity and B is the y-intercept. That's the position of the ball at t equals 0, essentially when my video starts. And here's the numeric values. So we can see for A, we've got a velocity of negative 0.72 meters per second, which seems reasonable for the rate that I push that ball, that it's moving at about just under 1 meter per second. And the B doesn't mean that much to us, but the velocity is an interesting number. Now we can do the same for Y. I go back over here, again put the leftmost key on the X, click on it, switch to Y, put the mouse on one of the points, do a right mouse click, go to Analyze, and there it is. There's Y. I can notice here now I can toggle. I can show X. So there's X, or I can show Y, And there it is. And I can actually turn off those lines too. There you go. And I can do analyze, and notice this is the best fit line for this data. It's also used y equals at plus b, where a is the velocity in the y direction. And here notice we have a positive number, 0.687 meters per second. That's the velocity in the y direction. Notice this number changes when I go up here, click the leftmost key, switch to x. Now the line is going through my x data, and it's giving me the velocity in the x direction. Go back to y, and it gives me the velocity in the y direction. And notice that's a positive number because the velocity in the y direction is a positive quantity, and it's negative in the x direction. Now that's the type of stuff that you're going to be doing when you study a toss ball. It's going to be a little bit more complicated, but essentially going through these steps to extract some information out of it is exactly what you're going to be doing. So go through this video a few times. Make sure you got down the bases, and we'll see you in the lab.